Unit 2 Solving, Lesson 2, Adding Linear Expressions. A linear expression is an algebraic expression in which the exponent of the variable is 1. For example, negative 4x, that's x to the first power, it's linear. An example of not linear would be x squared, that's x times x. Basically, the term can only have one variable in it. 3x plus 5 is okay. Negative 7x cubed plus x is not okay because there are 3 x's in this term. 5 minus 1/6 x is okay, but x to the 5th plus 1 is not okay. Another example of what wouldn't be okay is like xy plus 3. A term can have no more than one variable in it. So, vocabulary term, expression. An arrangement of mathematical symbols into a math sentence. An expression can include numbers, variables, operations, symbols, parentheses, punctuation marks, and functions. For example, 3 plus 7 is an expression. X plus 17, 6y plus 13y, negative 5. F of x plus 3, this is actually including a function. We won't talk about those until 8th grade. It can include operators you're not familiar with yet. This right here is the integral of x squared dx. This next thing is what's called the quadratic formula. The opposite of b, plus or minus the square root of b squared minus 4ac, all over 2a. Those are all examples of expressions. It's an arrangement of mathematical symbols into a math sentence. Okay, a linear expression is an expression consisting of only linear terms. Remember, linear expressions need to have only linear terms. They have at most one variable factor in the term. So examples of linear expressions, 2x plus 6y minus 7, okay. 5k plus 6k, 0. 3x plus 7, those are all fine. Non-examples, 5x plus 5x squared, no, the x squared is a problem. 3bf minus 7h, bf is a problem. Can't have more than one variable in a term. All right, at 5 to the x, we actually have a variable in the exponent. That is not going to be linear. Can't have variables in the exponents for linear. Okay, to find sums, there's two methods. First, the vertical method. You can stack and add, lining up like terms. So right here we have the constant terms, negative 2 and 8 make 6. Then we have the x terms, x and 3x make 4x, giving us the answer 4x plus 6. Okay, another way, this is actually more common, the horizontal method. Use the properties of operations to group terms and simplify. Right here, we can get rid of these parentheses because they are not doing anything to change the value of the expression. The associative property lets us get rid of them. After we get rid of them, we are looking for like terms. We've got negative 4y and 11y. Negative 4 plus 11 is 7, so 7y. We can also take a look at 3 and negative 5, and these go together to make negative 2. This gives us the answer of 7y minus 2. This is the more often used method, is to just take care of parentheses and then add like terms. Okay, find 2 times parentheses negative 5z plus 3 plus parenthesis 5z minus 2. First, take care of parentheses. These parentheses on the right don't do anything, so I can just get rid of them. These on the left do. In order to get rid of them, I'm going to have to distribute the 2. So 2 times negative 7.5 is negative 15z. 2 times 3 is 6. Okay, I've got it all in one nice list from left to right. I'm just going to add like terms. I've got negative 15 and 5. Those go together and make negative 10z. I've got 6 and negative 2, which go together to make 4. Okay, next example. Find the sum x plus 3 plus 2x minus 1. The x plus 3, the parentheses don't do anything, so I can just get rid of them. And the 2x minus 1, the parentheses don't do anything, so I can just get rid of them. Like terms, x and 2x make 3x. 3 and 1 make 2. So 3x plus 2 is the answer. Next example, negative 8z plus 4 plus 8z minus 7. These parentheses don't do anything, so I can just get rid of them. Negative 8z and 8z make 0z. 0z. 0z is just 0. I actually don't even need to write that. 4 and negative 7 make negative 3. So I get negative 3 as the answer. Next example. 4 minus n plus 2 times parentheses negative 5n plus 3. The first set of parentheses don't do anything. I can just get rid of them. The second set require distributing. 2 times negative 5 is negative 10. 2 times 3 is 6. Looking for like terms, I see negative n and negative 10n. That makes negative 11n. Remember that negative n is negative 1n. So negative 1 and negative 10 is negative 11. 4 and 6 make 10. So I get negative 11n plus 10. Next example. 1/2 w minus 6 plus 1/4 w plus 12. We cannot just get rid of these parentheses by erasing. We do have to distribute on both of them. 1/2 times w. 1/2 times negative 6 would be negative 3. 1/4 times w is 1/4 w. 1/4 times 12 is 3. Okay, like terms. 1/2 plus 1/4. 1/2 plus 1/4 is 2/4 plus 1/4. It's 3/4. So 3/4 w. And then negative 3 and 3 add to 0. So I don't need to write plus 0. 0 is just a placeholder. So 3/4 w is the answer there. Next example. We're going to start looking at finding differences or subtracting. The vertical method, you will stack it. This one's not used very often, but notice that I am subtracting. You want to add the opposite, so we changed both signs. Opposite x became x, and 6 became negative 6. And then you add straight down. 6 and negative 6 make 0. 5x and x make 6x. So 6x plus 0. The answer here ends up being 6x. Okay, the horizontal method is more commonly used. We just use the distributive property. And you can distribute negatives just by changing the sign of everything inside, because negative just means the opposite of. Okay, this first set of parentheses don't do anything, so I can get rid of them. The second set require me to distribute. I'm going to distribute negative 2. Negative 2 times 4 is negative 8. Negative 2 times negative 3 is positive 6. Then I do my like terms. 7 and negative 8 make negative 1y. 5 and 6 make 11. I've added my like terms. Now I'm done. So in order to subtract linear expressions, you add the opposite. Okay, let's do another one. M minus 3 subtract negative m plus 12. I'm going to need to distribute the subtraction. Basically, I'm going to add the opposite. The first set of parentheses I can just get rid of. They're not doing anything. The second set, the opposite of m is m. The opposite of 12 is negative 12. And then like terms, m and m make 2m. Negative 3 and negative 12 make negative 15. Okay, next example. Negative 2 times c plus 2.5 minus 5 times 1.2c plus 4. Distribute on both of these. We can't just get rid of any of these parentheses. We've got to do some distributing. Okay, I'm distributing negative 2 times c, that's negative 2c. Negative 2 times 2.5 is negative 10. Negative 5 times 1.2 is negative 6. Negative 5 times 4 is negative 20. We've got an awful lot of negatives in this expression. In fact, they're all negative right now. Negative 2 and negative 6 make negative 8, so negative 8c. Negative 10 and negative 20 make negative 30. So when I simplify, I get negative 8c minus 30. When adding linear expressions, the distributive property will often be used, followed by adding like terms. Add or subtract each set of linear expressions. 3d plus 13 plus 2 times negative 4d minus 4. So this is in your notes. Please write it in your notes. we're going to have to distribute the 2 on the second set of parentheses. The first set of parentheses I can just get rid of because they don't do anything. 2 times negative 4d is negative 8d. 2 times negative 4 is negative 8. Now looking at like terms. 3d minus 8d, that would be negative 5d. 3 minus 8 is negative 5. 13 and negative 8 make 5, positive 5. So the answer, negative 5d plus 5. Example 211. X plus 1 minus 9 times x plus 1. Well, I need to distribute the negative 9. So x plus 1 minus 9 times x, negative 9x, negative 9 times 1, negative 9. So x minus 9 is negative 8, so negative 8x. 1 minus 9 is negative 8. So I get negative 8x minus 8. Example 212. 2 times 9t minus 6 plus 4 times 6t minus 9. I'm going to have to distribute in both cases here. 2 times 9 is 18, so 18t. 2 times negative 6 is negative 12. 4 times 6 is 24, so 24t. And 4 times negative 9 is negative 36. Combining like terms, or adding like terms, I mean. 18 and 24, let's see, that would be 42. 42t. Negative 12 and negative 36 is negative 48. So 42t minus 48. Example 213. 7 times 2y minus 4 minus 11 times 3 minus y. Well, 7 times 2y is 14y. 7 times negative 4 is negative 28. Negative 11 times 3 is negative 33. Negative 11 times negative y is positive 11y. Negative times negative gives you a positive there. So, adding like terms, I've got 14y and 11y. That makes 25. Yeah, 14 plus 11, 25y. Negative 28 and negative 33. They're the same sign, so I'm going to add them and keep the sign. I get 61, negative 61. So 25y minus 61 is the answer for example 213. Okay, next, write the expression to represent the A perimeter and B area of the rectangle. Now on your notes this number didn't print, so you'll need to put in the number 13 on the side of the rectangle. First, perimeter. If this side is 13, the opposite side is 13. If the top is 3x plus 5, the bottom's 3x. Oh, I mean minus 5, 3x minus 5. So the perimeter is going to be 13 plus 3x minus 5 plus another 13 plus another 3x minus 5. So these parentheses don't do anything. I don't need them. So I guess just kind of get rid of them. So like terms, I've got 3x and 3x. That makes 6x. I've got 13, negative 5, 13, and negative 5. Well, 13 minus 5 is 8. And another 13 minus 5 is another 8. I guess that's 16. So the perimeter is 6x plus 16 units. I guess we don't know if it's feet or miles or whatever, so they're just units. The area is length times width, so we're going to do 13 times 3x minus 5. And then we will distribute the 13. 13 times 3 is 39, 39x. 13 times negative 5 is negative 65. So the area is 39x minus 65 square units. Square units because it's area. Okay. Next, we're going to be starting on the assignment. You'll want to get that out. I'm going to preview a couple of the problems to help you out here. Number 1, find each sum. And you got 6 problems here. We'll go ahead and do one of them together. On On this first one, part A, these parentheses aren't doing anything. There's nothing I need to distribute, so I can ignore them. Like terms, n and n make 2n. 8 and negative 12 make negative 4. The answer to 1a is 2n minus 4. Okay, number 2, we're going to find the difference. So same process here. There's nothing to distribute on this first set of parentheses, but since I'm subtracting, I need to add the opposite here. So I'm going to copy down the first set of parentheses and then change the signs inside the second set. So the opposite of g and the opposite of 11. So minus g minus 11. Then I go to add like terms. Negative 2g and negative g make negative 3g. 7 and negative 11 make negative 4. So I get negative 3g minus 4 is the answer on 2a. Number 3 is a review problem. Well, no, it's not a review problem per se. I guess it's something you could have done in 6th grade, but you're going to put parentheses in the expression to make it so that it's true. So 5 times 4 plus 5 is 45. Order of operations would have us multiply first, and we get 20 plus 5, which is not 45. So you need to put parentheses in here to make that work. Now 5 times 9 is 45. So I could put the parentheses in there and it would work. On number 4, you're going to find the mean of the set of numbers. Remember, add them up, divide by 5 because there's 5 numbers. Number 5, you're going to find the area of the parallelogram shaped block. And that's something you went over in 6th grade. Number 6, modeling with mathematics. This is a review from 6th grade in writing expressions and interpreting what they mean. Number 7, the expression 17n plus 11 represents the perimeter of the triangle. Write an expression that represents the measure of the third side. Okay, let me give you a hint on this. If I told you that the perimeter of a triangle was 7, now let's make it 8. If I told you the perimeter of a triangle was 8, and you knew one of the sides was 3 and one of the sides was 2, and you had to figure out the other one, you would just take the total perimeter and subtract off the other 2 sides to figure out what the missing side is. You're going to do that exact same thing here. Take the full perimeter and subtract off this side and subtract off this side, and what is left over will be the third side of the triangle. Number 8. A linear expression is one in which all variables have no exponents other than the exponent 1, x to the first because it's just x. And variables are not multiplied to other variables. Study the examples of linear and nonlinear expressions. Essentially, each term can have at most one variable factor. So these are yes/no questions. Is 3x plus 7 linear? Well, this term only has one variable in it, and this has no variables, so this one is okay. It can have at most one variable in each term.